For centuries, buildings have stood as silent giants, static structures designed to withstand the test of time. We erect walls, lay foundations, and construct roofs, creating shelters that remain largely unchanged throughout their lifespan. But imagine a world where buildings are no longer passive bystanders. Picture structures that can sense, learn, and adapt to their surroundings and the needs of their occupants. This is the promise of dynamic architecture, a revolutionary concept poised to redefine our relationship with the built environment. Traditional buildings are limited by their fixed designs. A room built for a specific purpose remains tethered to that function. Dynamic architecture, however, breaks free from these constraints. Imagine a home where walls seamlessly reconfigure to create open living spaces or private rooms as needed. Picture offices that morph and adapt to different work styles and team sizes throughout the day. This is the allure of adaptive buildings, spaces that are fluid, responsive, and in sync with the rhythm of life. The transition from static structures to dynamic habitats marks a profound shift in our approach to architecture. It's about infusing intelligence into the very fabric of our buildings, enabling them to learn from their surroundings and respond in ways that enhance our comfort, well-being, and productivity. It's about creating spaces that are not merely containers for human activity but active participants in our lives. At the heart of dynamic architecture lies a sophisticated interplay of cutting-edge technologies. Dynamic neural architecture, as it's known, hinges on the remarkable capabilities of neural networks, sensors, and adaptive materials. These three components work in harmony, forming the brain, nervous system, and responsive muscles of buildings that can learn, adapt, and transform. Neural networks, inspired by the intricate workings of the human brain, form the cognitive core of adaptive buildings. These networks excel at recognizing patterns, learning from data, and making intelligent decisions. In the context of dynamic architecture, neural networks process vast amounts of information from various sensors embedded throughout the building. They analyze data related to temperature, lighting, occupancy patterns, and even external factors like weather conditions. Sensors act as the sensory organs of dynamic buildings, constantly gathering information about the building's internal environment and external surroundings. These sensors are strategically placed throughout the structure, akin to a network of nerves, relaying real-time data to the central neural network. Temperature sensors monitor thermal comfort, light sensors assess illumination levels, and motion sensors detect occupancy patterns, providing the neural network with a comprehensive understanding of the building's dynamics. Adaptive materials, the responsive muscles of dynamic structures, hold the key to transforming data-driven insights into physical changes within the building. These innovative materials exhibit remarkable properties, allowing them to alter their shape, color, or transparency in response to external stimuli. Imagine walls that can adjust their insulation levels based on temperature fluctuations, or windows that darken automatically to reduce glare from the sun.